Okay, so we're going to be having a look at indifference curves, which basically show a person's preferences between two commodities. So I've just got a random graph showing indifference curves from the internet, showing commodity Y and commodity X. And they're basically the variations of those commodities at which someone would be indifferent to receiving on the same indifference curve. So say point Y0 on the graph was, I don't know, 2 pancakes, and point X0 was 2 drinks of Coca-Cola. They would be indifferent to receiving these commodities at point A, so 2 pancakes, 2 Coca-Cola at point A. They'd be indifferent to receiving them as at point X1. So let's say that is 3 drinks of Coca-Cola compared to 1.5 pancakes, and we'd put that as another point on the indifference curve, and we'll just call that point E. So, sorry for my bad drawing. Point A and point E are on the same indifference curve, which implies they have the same marginal utility to the person whose preferences these represent. So we'll call it U1 for utility 1, and we'll call this indifference curve U2 for utility 2. So the person at U1 is not bothered about any combination of commodity Y and commodity X on this indifference curve. They are equally happy no matter what combination they get. However, because U1 is of lesser marginal utility than U2, because at any point on U2, he's going to be receiving more goods, isn't he? So every point on here is higher than at this point, so more is always better, so they're receiving more goods at every point on here. So you'd say point A provides him with less utility than point C, because point C is on a higher indifference curve. However, point D and point B are on the same indifference curve, so they all provide them with the same marginal utility. Now, there are going to be many indifference curves. This only shows 2, but you can imagine for a person they're going to go out like that. As they get more goods, they're going to become more valuable every time. So it's a bad drawing. Going up like that. Increasing in utility each time, so getting more of the combinations of goods. So, you are equally happy with any combination of variables on the graph that are on the same indifference curves. For example, combinations of pancakes and Coca-Cola, as we mentioned before. Both variables bring us utility, so we always want more of them. And you can easily remember this with the saying more is always better. Since more goods provide us with more utility, 2 of each is preferred to 1 of each. With regards to different combinations of goods, you might be indifferent to receiving 3 pancakes to 1 drink of Coca-Cola. The line which combines the combinations of goods that provide you with a certain degree of utility is called the indifference curve, and each point represents the same level of utility on that indifference curve, as we mentioned earlier. We can have several different indifference curves that all show indifference between different combinations of goods at different utilities, with utility increasing as you go up in this direction. Indifference curves never overlap, as this suggests indifference at different levels of utility, which doesn't make sense, as you always want to maximize utility by having more. So if we were to imagine we had another indifference curve that went through point A, and let's say this is of U1.5, because it's going to be less utility than U2 at all points. Well, that is impossible, because it's implying that it is of 0.5 points more utility than at U1, even though it's overlapping with point A, which is said to be at utility 1. So how can that be? It's the same combination of commodities, but apparently it's got a high utility. That's impossible. So that's why they can't overlap. Indifference curves aren't straight lines, as its slope changes as you move between different combinations of goods. So basically, as you get more of commodity X, say we said that was Coca-Cola, as you get more Coca-Cola, you're less willing to give up each pancake for another piece of Coca-Cola. So as you go down here, you're getting less and less pancakes each time for commodity Y, and each time you're getting more of commodity X. However, at each point, if we're going to calculate the slope at each of these points, we can see that the slope is much higher here than it is here, because at this point you've given up more of commodity Y, so you're less willing to give up more pancakes to get more Coca-Cola as you have more Coca-Cola. So if you're talking about supply and demand, since you have lots of Coca-Cola, you're kind of, if you got 5 cans of Coke, and you also like pancakes, you're going to be less willing to give up, say, another 2 pancakes for 1 can of Coke, because you're already content you've got loads of Coke and you also like pancakes, so you might as well get more pancakes for your money. So basically, putting this mathematically, we're going to look at the slope here and calculate it as V over H. Sorry for my bad drawing. V over H, let me just redraw that. Let's say this is a value of 2 and this is a value of 1. 2 over 1 equals 2. So the slope at this point is 2. And let's say because the slope is decreased at this point, it is 1 and 1. And then we're going to go 1 over 1, which is 1. So the slope has decreased. Now, why am I telling you all this? Obviously, you already know about calculating the slope of a graph. Well, the slope of each point of the indifference curve is the same as the MRS, which is the marginal rate of substitution, which basically means how much, sorry for my bad drawing, how much you're willing to give up at each point. So at this point, you're willing to give up 2 pancakes for 1 can of Coke, whereas here you're only willing to give up 1 pancake for 1 can of Coke. So your marginal rate of substitution has decreased as you go down. because the slope of the indifference curve has decreased in itself. I think that's fairly self-explanatory. Let me just clear off all this rubbish now, so we don't need it. Now, let's add the idea of putting a production function into here. So let's say this is the line of the production function. It's the marginal rate of transformation. So let's say you can only afford a certain amount of them. You're going to pick point D because this is where the marginal rate of substitution is equal to the marginal rate of transformation, which is just the same as your production function. So everything within here is possible to you. This is an oversimplification, but everything out of here is impossible because let's say you can't afford it, but you're spending £10 and you're trying to decide which combination of goods you can buy. So your production function is £10. Let's say they both cost the same. You don't know what combination to get because you like them both equally. Well, it looks like that's about, if it was a perfect curve, that would probably be about 5 on each. So you get about 5 pancakes, 5 cans of Coke if they both cost £1. So you like them both equally. Obviously, it depends on the slope of the indifference curves. 5 on each. But basically, the point to take is, when you're looking at a graph, the point where MRS is equal to MRT is going to be point D, where the feasible frontier, or the MRT, is equal to the marginal rate of substitution, represented by the indifference curve. So the slope of the indifference curve is called the marginal rate of substitution, and it measures the rate at which you are willing to forego a good to get more of another, while keeping your utility constant. The easiest way to find the MRT on an indifference curve is to draw a straight line at a tangent to the curve at each point. The slope of each tangent decreases as you go down the graph, which indicates a decrease in the marginal utility of substitution. So that's basically what we did before, but instead of doing that, they've just done that first to get a proper tangent. Let me just clear this off. The slope of each tangent decreases as you go down the graph, which indicates a decrease in the marginal rate of substitution, like we said before. This is a result of marginal utility, as each additional can of Coke provides you with less utility than the previous one. So you are less willing to give up pancakes as the fewer cups of Coke you have. The higher their marginal utility, so the fewer pancakes you have, the more marginal utility they have, basically. So you're less willing to trade them for more cans of Coke. You've already got loads. If more is not always better, for example pollution, the indifference curves arc in the other way. So they look like that instead of like that. If you want less of something, so you'd rather have less. So let's say, actually no, that is true, but I'm not going to go for an example because it'll take too long and we've already been here for a while. Most indifference curves are bound inward, like these ones. as MRS changes depending on the amount of the goods you have and your willingness to substitute between them. In other examples, if you view goods as substitutes and are equally happy with either of them, for example, 3 cans of Fanta to 1 can of Coke, the MRS would be constant along your indifference curve and would look like a straight line. So if you're not bothered, they're not sloping like these ones, they're just straight lines. Same, you can have goods that you only value together. So Maya lecturer used the example of socks. Well, you're not going to get much utility from, like, if you had 3 socks. They provide you with the same utility as 2 socks because they are perfect complements. You don't get any use out of 3 socks, you're only going to wear 2. So your utility would look something like that, a right angle. So you'd see 1 sock there, 1 sock there. You're no better off if you have 2, 3, 4. You're not going to be better off because you can only use each of them. I know technically if you're going to say you can have 3 in that and that would be high utility, you can use the example of shoes as well. So if we think of it like these are left shoes, you can have 4 left shoes and 1 right shoe. It's not going to provide you with any more utility, but you increase utility as you go from 2 to 3. Hopefully that makes sense. Anyway, that's it for indifference curves and marginal